A good portion of the United States is designated as mountainous terrain, and every year dozens of pilots crash in these areas. Many of these accidents could have been prevented through proper education and flight training. When preparing for a mountain flight, the first thing you should do is get a mountain checkout.
Welcome to Colorado.
Thank you. How are you?
Good, very good. How are you?
Thanks.
I hear there were some pretty severe storms out in parts of the Midwest.
Yeah, I had some bad weather over Nebraska, but nothing serious.
Good. Well, you made the right decision stopping by for a mountain checkout. Why don't you go ahead and have a seat there?
I didn't want to take any chances. I've never flown in the mountains before, and I really want to be well prepared.
I wish more pilots had that attitude. Well, this afternoon, we'll go over some pre-flight considerations. Then first thing tomorrow, we'll do a short mountain flight. Our goal in this program is to familiarize you with certain mountain flying techniques and not to turn you into a bush pilot. We'll be flying to several paved public use airports at high elevations or in mountainous terrain. Let's begin by watching a videotape that provides good pre-flight planning techniques for mountain flying. If you have any questions, feel free to speak up and I'll stop the tape.
Pre-flight planning is necessary for every flight, but it's particularly important in the mountains where special considerations have to be made for weather, airport operations, course selection, and aircraft performance. One of the first things you may discover is that it can be difficult to get an accurate, comprehensive weather briefing for a mountain flight. There are several reasons for this. One is the fact that reporting stations are normally more scarce in the mountains. Those stations that do report often have limitations on how much of the surrounding area they can see because of ridges and other terrain which block the view. Another source of surface weather observations is AWOS. These systems only report very localized weather, and therefore extra caution must be taken to be sure you have accurate information on the areas outside of the AWOS range. Mountains also tend to influence or create their own weather. This can result in rapidly changing conditions, so great care must be taken when preparing to fly into those areas. For these reasons, it's difficult to accurately forecast local and en route weather. In order for you to get the most complete weather picture possible, use as many sources as you can think of. Additional sources include calling ahead to airports along your route to get first-hand information, or even calling the Forestry Service or local law enforcement agencies. When obtaining weather, there are a couple of areas you need to pay special attention to. The first area includes ceiling and visibility. VFR weather reports in the mountains can be very misleading because the ceilings are reported above ground level and many mountain airports are located in valleys. This means that even though the airport meets the legal definition of VFR, surrounding mountains and terrain may be obscured by relatively poor weather. So you should consider the difference between the field elevation and that of the surrounding terrain to determine if you can navigate VFR over the higher areas. The second section you should pay special attention to during the weather briefing is wind reports. As a general rule, winds at the mountaintop greater than 30 knots should be considered a limit for operating a light, general aviation airplane in the mountains. The reason for this is that Venturi effect caused by the mountains and upper-level winds can accelerate the flow of wind as it passes over mountaintops. This can double or triple the wind speed, resulting in extreme up and down drafts and making travel in a light aircraft potentially dangerous. Also, strong winds combined with unstable air and mountainous terrain can induce severe turbulence that may exceed the capabilities of some airplanes. Finally, if the air is stable, winds of 20 knots or more flowing across ridges can produce mountain waves. These waves flow downwind of the mountainous terrain and may extend for hundreds of miles. Since these waves are capable of producing severe turbulence, they should be avoided if possible. If sufficient moisture is present, there are some very characteristic clouds that can warn you of the presence of a mountain wave. The altocumulus standing lenticular, or lenticular for short, forms in the crest of the waves. This type of cloud is found in the middle altitudes. It's constantly forming in the updrafts of the wave and dissipating in the downdrafts. The term standing lenticular comes from the fact that it appears as a stationary, lens-shaped cloud. Cap clouds form much the same way as the lenticulars, but they are usually found at the mountain tops and along the ridges. These clouds can obscure the mountain peaks and ridges and may indicate turbulent conditions. Rotor clouds form downwind of the ridge. The significance of a rotor cloud is its ragged and rough texture, which is indicative of severe turbulence. Pre-flight planning should also include airport considerations. Anytime you're flying into an unfamiliar airport, be sure to check all available sources for the latest and most accurate information. One source for that information is published NOTAMs. You should check all available NOTAMs before flying to or from any airport. Reviewing the airport facility directory can also help you become familiar with each airport, especially the runway layout, special procedures, and the surrounding terrain. It's a good idea to envision the terrain around an airport by using the airport facility directory in conjunction with a sectional. This can help you draw a mental picture of obstructions and terrain around the airport before you even arrive. Finally, you should call ahead to get the latest local information. For example, during the migratory season, you should ask about the possibility of animals on the runway. This is especially true if the airport is near heavily forested areas. In addition, if there is snow in the forecast, a phone call can alert you to snow removal operations. The hours of operation and services available can also be verified. This is important because your ability to obtain fuel or other services at a mountain airport may dictate whether or not you can complete a planned trip. Now, let's shift our attention to course selection. Most pilots navigate using some form of radio aids like VOR or LORAN. However, take a look at this segment of Victor 134 between Denver and Aspen. It has several peaks higher than 13,000 feet. Aircraft performance is a critical factor at these high elevations. And navigating along this airway would take you over some very inhospitable terrain. In the mountains, weather, performance, your capabilities, and the terrain often make following valleys, rivers, highways, or railroads a much better choice than going direct over unpopulated or rugged terrain. This also affords numerous landing sites in case of emergency, and might mean that you can make the flight without supplemental oxygen. Therefore, instead of flying the airway to Aspen, a better route might be to fly over Corona Pass to Kremling, then follow the Colorado River to just west of Eagle. From there, you could follow the valley into Aspen along the Roaring Fork River. This route follows valleys and lower terrain and reduces the performance requirements of the airplane. It also allows for a safer route in case of an emergency by providing more suitable landing areas.
Another important consideration during your pre-flight planning is to calculate your airplane's takeoff performance to ensure that all the runways are long enough for your airplane. This is especially true at mountain airports where high-density altitudes will decrease your airplane's performance. Remember, airplanes land in a shorter distance than they take off in. So it's important that you calculate your takeoff distance at all the airports that you intend to use. Now let's take a look at how airplane weight, runway condition and slope, and high-density altitude affect performance.
Your operating weight should be carefully considered when flying in the mountains. Reducing your takeoff weight below the maximum allowable gross weight can improve your aircraft's takeoff distance and climb performance. For example, the takeoff distance for this airplane, weighing 2,950 pounds, is 2,770 feet. Reducing the weight by 200 pounds reduces the distance required to clear a 50-foot obstacle by 500 feet. The condition and slope of the runway can also have an effect on your airplane's performance. However, most manufacturers don't provide data for operating on snow-covered runways, wet runways, or runways with a slope. Therefore, you need to be familiar with your airplane and use your best judgment. For example, if the wind is light, you might find it more beneficial to take off downhill with a tailwind rather than uphill into the wind. Remember, though, that many times the main criteria for determining takeoff direction at mountain airports is the terrain immediately beyond the runway. Just remember that if you're ever in doubt as to the outcome of a particular operation, you should delay the flight until more favorable conditions exist. Finally, a high-density altitude greatly affects takeoff distance. This is because as density altitude increases, the performance of an aircraft, especially a normally aspirated engine, decreases. The same holds true for propeller efficiency and aerodynamic lift. You may be familiar with density altitude at much lower airports where the temperatures can exceed 100 degrees. But a mountain airport may have a high density altitude when the temperature is as low as freezing. It's hard to imagine that density altitude could be a factor at such low temperatures, but it's a problem anytime the temperature is higher than standard for the field elevation. For example, Leadville, Colorado has a field elevation of 9,927 feet. Therefore, the standard temperature is 23 degrees Fahrenheit. This means that even with the temperature at the freezing level, the density altitude is already more than 500 feet above the field elevation. Performance also depends on the fuel and air mixture. Operating at an incorrect ratio decreases the amount of power your aircraft is capable of producing and consequently decreases performance. To ensure you're operating at the most efficient ratio, you should always lean the mixture per the manufacturer's recommendation. Climb performance also changes with density, altitude, and weight. For mountain operations, many experienced pilots recommend a minimum climb rate after takeoff of 300 feet per minute as a go, no-go decision factor. If you can't achieve this rate, you might want to wait until the conditions improve. Remember, climb rates are dependent on holding a specific airspeed. Normally, this is Vy. But as altitude increases, the best rate of climb airspeed decreases. Be sure to use the speed appropriate to your altitude and weight and not the sea level figure. When considering aircraft performance, many pilots believe that if they have an aircraft with a turbocharged engine, they don't have to worry about density altitude. However, this isn't the case. Turbochargers only allow the engine to produce sea-level power. In the thin air at high-density altitudes, the propeller cannot translate all of the engine power into thrust, and the wings require more true airspeed to produce the lift necessary to fly. As a result, performance still suffers.
Something you want to be aware of is that some manufacturers don't provide performance information for operations out of high-altitude airports. When I operate to or from an airport where I cannot calculate the takeoff performance from the charts, I use one of two devices. This is the takeoff performance computer, and this is the cost chart. Now, you may not be familiar with these devices, but they adjust the sea level takeoff, ground roll, and climb rate performance for ambient conditions. However, if you do decide to use one of these two devices, there is one thing that you should realize: they are not made for a specific make and model of airplane. What they do is provide general estimates of airplane performance. Now, I know you fly a single-engine airplane right now, but in the event you decide to transition to a twin in the future, there are a few things that you should consider.
An engine failure in a twin on takeoff at an airport with a high-density altitude possesses some unique challenges because accelerate stop and accelerate go distances may be greatly increased. While it isn't a regulatory requirement, if a takeoff looks marginal during your pre-flight planning, you might want to wait for better conditions or offload some weight to improve single-engine performance. If you lose an engine above the single-engine absolute ceiling, you're going to descend until reaching this altitude. This is called drift down. If the terrain happens to be higher than the single-engine absolute ceiling, you're going to have to make an off-airport landing unless you've planned carefully and are in the vicinity of an airport. If the terrain is lower and remains lower than this ceiling, you should be able to fly to an airport. In either case, your ability to overcome downdrafts and control the airplane in turbulence will be complicated by the decreased performance and the adverse handling characteristics inherent with single-engine flight in a multi-engine aircraft. Besides the weather briefing, airport and performance considerations, and route planning, other areas of interest during pre-flight planning include navigation methods, time of day of the flight, and survival. Since the primary methods for navigating in the mountains will most likely be pilotage and dead reckoning, you should be proficient in this type of navigation. This is important because when comparing terrain, one peak or valley can look just like the next. In addition, you should use a sectional instead of a WAC chart because it provides more detail and information. To help verify your position, be sure to use as many ground references as you can. And use radio navigation where available. If you have a choice of the time of day for your flight, the mornings are generally best. The cool morning air lowers density altitude and may lessen convective activity. However, morning flights are not without a downside. The low sun, as it rises in the east, can be distracting and make it difficult to see surrounding terrain. Keep this in mind if you're planning an eastbound flight. Perhaps you can plan your course to avoid looking directly into the sun. And unless it's absolutely necessary, you should not attempt to fly in the mountains at night. The lack of visual contact with the ground, combined with the normal nighttime illusions, make this a dangerous practice. Another consideration is survival. Since mountainous terrain is more rugged and less hospitable than other types of terrain, you must be prepared in the unlikely event that you're forced to make an off-airport landing. We've already discussed route selection for the purpose of navigation, but a good route should also provide survivable terrain. For instance, valleys mean lower elevations and subsequently higher temperatures, while roads usually mean population and a better chance of being spotted if you're forced down. One way to increase your chances of survival is to file and then activate a flight plan. With a flight plan, chances are you'll be found within 24 hours. Without one, the average time for rescue increases to 3 days. And to aid in search and rescue, be specific when you file the flight plan. If your route follows a road or river, list them as your route of flight. Then during the flight, make position reports so there is a record of your progress. If you do have to make an emergency landing, a survival kit, ELT, and handheld two-way radio will make it easier for someone to find you and to help you cope with the elements. Survival kits are available commercially, or you can make your own. The survival kit should contain supplies that will allow you to treat injuries, provide for shelter, food, and water, and enable you to signal rescuers. In addition, you should carry enough clothing to protect you from the elements in case you have to land in inhospitable terrain. An ELT is required for most flights and should be considered mandatory in the mountains. Make sure the ELT is working and that the battery has been replaced according to the regulations. A handheld two-way communications radio is good insurance. In case the aircraft radios are unusable, it allows you to communicate with overflying aircraft as well as search and rescue teams.
One of the last things that you need to do for any flight, and especially a mountain flight, is make a good go, no-go decision. If you have the slightest doubt, don't go. Too many pilots have been killed because they couldn't miss one good day of skiing. All right, let's go ahead and plan the cross-country from Jeffco to Aspen. But unlike the video, we'll go from Kremling to Glenwood Springs and then to Aspen. Okay, one of the things we want to work on is picking out some distinguishable checkpoints. In the mountains, it's difficult to recognize the same corresponding features on the ground. Your flight plan looks good. Let's call for an outlook briefing. Then tomorrow morning, we'll call for a standard briefing. If everything looks good, we'll go ahead and fly the route.
Good afternoon. I'd like an outlook briefing on a VFR flight from Jeffco to Aspen. 1400. Good morning, sir. I'd like a standard weather briefing on a VFR flight from Jeffco to... Yes, I'd like to file a VFR flight plan. November 423 Charlie Charlie, PA.
Boy, we sure picked a beautiful morning for this flight. Okay, one of the first things we have to do is find Corona Pass. But in the meantime, let's make a few turns, gain some altitude before we reach the pass. Notice that Corona is listed on the sectional, and it has a 12,940-foot peak to the north and a 13,294-foot peak to the south. See that ridge straight ahead? That's where we'll cross Corona Pass. Now, we can verify this is Corona Pass by checking to see if we're approaching Victor 8, which is the 268-degree radial from Denver.
While flying in the mountains, it's a good idea to fly as high as practical, keeping in mind the limitations of the airplane and the oxygen requirements. Where practical, many experienced mountain pilots maintain a minimum of 1,000 feet of terrain clearance within 3 miles of their position. This should help guard against encounters with rough air and provide enough altitude to glide to lower terrain in case of an emergency. If the wind speed increases, so should your altitude. For example, in a 20-knot or greater wind, you might want to increase your terrain clearance to 2,000 feet. At times, however, it's going to be impossible for you to fly at high altitudes. If this is the case, there are several techniques and precautions to be aware of. Situational awareness is very important. Knowing where you are, where you're going, and where your escape routes are may make the difference between surviving an emergency or not.
It's very important in mountain flying to always keep track of your position. If you lose track of where you are, you could easily end up lost. One way I check myself is by comparing my desired magnetic heading to my actual heading. For instance, when we go from Glenwood Springs to Aspen, we'll be flying a heading close to 130. If our heading was 09 or 0, we could be flying up the wrong valley. Look ahead of you, see all the emergency landing sites? That's the biggest reason for selecting this route, along with the fact that we can now descend to a lower altitude. Now that we've crossed Corona Pass, our next checkpoint is Kremling. Notice the mountain ridge just southeast of Kremling. We want to fly towards that ridge.
While flying in areas with rising terrain, one of the first things you'll have to adapt to is a different reference for the horizon. Many pilots new to mountain flying tend to use the tops of the mountains as the horizon reference. This causes them to fly in a nose-high or climb attitude. To maintain a level flight attitude, you need to superimpose the horizon at the base of distant mountains. You will also want to occasionally cross-check the instruments to make sure the aircraft is performing the way you want it to, and to detect problems as soon as they occur. Another consideration in mountain flying is the visualization of up and downdrafts. As wind flows perpendicular to a ridge or mountaintop, it has a tendency to flow uphill on the windward side and downhill on the downwind side. By knowing the wind direction, you can get a pretty good idea where the updrafts and downdrafts are located. But keep in mind that this is all theoretical, and any obstructions, such as smaller mountains, can cause downdrafts and turbulence even on the windward side. If you encounter an updraft, allow the airplane to climb unless there's a good reason for staying at your altitude.
One reason for staying at this altitude is the oxygen requirement. If we go above 14,000 feet, we're going to have to use oxygen. So let's try to maintain our altitude.
Remember, as you level off or try to maintain altitude in an updraft, your airspeed increases since you're actually descending through the air mass. Be cautious that you don't exceed any aircraft limitation. Whenever possible, avoid the areas where downdrafts might exist. Again, visualization is the key to achieving this goal. However, if you encounter sink, your primary concern is probably terrain. If you happen to get into a downdraft, having enough altitude to fly through it is very important. After applying full power, go to and hold the best rate of climb airspeed. Remember, Vy changes with altitude. If this isn't working, try maneuvering to an area where the sink might not be as great. Always retain the ability to turn your aircraft while descending. If it becomes apparent that you will make contact with the ground, continue flying the airplane, and whatever you do, don't pull back on the control wheel trying to gain altitude. In most cases, this will result in a stall. It's much better to make contact with the ground while still in control of the airplane than to stall and possibly spin. Just as visualization is the key to avoiding sink, it also is important for avoiding turbulence. The important thing to remember when you do happen to encounter turbulence is to stay at or below maneuvering speed. This ensures that the wing will stall momentarily before the aircraft suffers structural damage. Maneuvering speed, or VA, should be calculated for each flight based on the aircraft's weight. But remember to reduce it during the flight as fuel is burned. Now, let's see how this knowledge of updrafts, downdrafts, and turbulence can help us during ridge crossings and when flying in valleys. Again, visualization of the airflow based on the prevailing conditions will be important as you make ridge crossings. When crossing a ridge, select a heading that allows an escape route if something goes wrong. Normally, you should cross it at an angle of approximately 45 degrees. This allows you to quickly get to lower terrain by just making a 90-degree turn. If you were approaching the ridge straight on, you would have to make a 135-degree turn to get to the same location. As you near the ridge, you want to make sure that you're high enough to cross. You can easily determine if you're high enough by observing the terrain beyond the ridge. As you get closer to the ridge, you should see more and more of the terrain on the other side. When you can glide to lower terrain on the other side of the ridge, you can commit to the crossing. At this point, turn to depart the ridge at a 90-degree angle. This decreases your exposure time over the ridge and puts you over lower terrain as quickly as possible.
All right, the river down here straight ahead, that's the Colorado River. It kind of curves around the Kremling area. We have a lot of potential landing spots along the river valley, a lot more than if we were flying over the mountains to the south or to the north. This is the primary reason why we're flying down the river valley. The winds can also be a little turbulent down inside the valley, so it's very important that you know which direction the winds are from. This way you can visualize the wind flowing down one side and then up the other. This will also enable you to fly where there will most likely be updrafts and avoid those areas where there might be downdrafts.
When flying in the valleys, try to take advantage of the updrafts and try to avoid the areas of downdrafts. As we've seen before, the prevailing winds can cause areas of lift and sink, but convective activity can also produce up and down drafts. For example, flying in shaded areas, above water, or over heavily forested areas will most likely put you in a downdraft as cool air over these areas sinks and replaces the warm rising air. On the other hand, flying over areas where heating is taking place, such as an outcropping of rocks, may produce an updraft. Another consideration when flying in valleys is that terrain can often outclimb an airplane. Therefore, you must always leave yourself an out. This means being able to turn to lower terrain at all times and to never proceed up a blind canyon where there's no escape route. Just like any cross-country flight, you need to stay abreast of the weather. In the mountains, this is extremely important, but not always easy to do. Where possible, use FlightWatch to check on weather conditions along your route. When you can't reach FlightWatch on the standard frequency of 122.0, you may find it necessary to communicate using a remote communications outlet, or RCO. These communications outlets are depicted on sectionals by an encircled dot. There is also a communications box showing the frequency, remote name, and a monitoring flight service station. RCOs extend the range of flight service stations in mountainous terrain and operate in the same manner as other radio stations. Be sure you mention what frequency or facility you're using when you contact the FSS. You can also use Unicom along the route to get local weather information. However, unless the person on the other end is a trained weather observer, the most you will probably get is winds and altimeter settings. Perhaps your best source of weather information in the mountains is pilot reports. Because there are few weather reporting stations in the mountains, flight service stations and other pilots depend heavily on PIREPs. You can obtain and file PIREPs through FlightWatch, RCOs, centers, or by talking to flight service over VORs and other flight service frequencies.
Okay, do you notice that area of lower terrain up ahead? Well, when we reach that area, we're going to want to turn west to get to Glenwood Springs. All right, when we get to Glenwood, you're going to discover that operations at high-altitude airports differ from the airports you're used to flying into.
Some airports, for reasons of terrain, noise abatement, or runway slope, are one-way airports. This means that traffic has only one way in and out. For example, here at Glenwood Springs, if the wind permits, pilots are to use runway 32 for arrivals and runway 14 for departures. When operating at any airport, and especially a one-way airport, turn on your landing light and anti-collision lights if they are not already on. This makes it easier for traffic approaching from the opposite direction to see you. As we've already seen, mountains can create unusual wind flow patterns. Therefore, it's important to assess wind conditions as well as turbulence and obstructions caused by the surrounding terrain as you approach to land. While you assess these conditions, you should also plan for a go-around in case something happens and you can't complete the landing. While you're beginning the go-around is not the time to be making these decisions. Another thing to consider is that if the airport you're flying into allows for a traffic pattern, chances are you'll overshoot the turn to final, especially if this is your first attempt. This is because your true airspeed is higher at the higher elevations, even though your indicated airspeed is the same. But don't slow down to compensate for the increase, because the higher true airspeed is needed for the wing to produce the same amount of lift as it would at lower altitudes. Instead, widen your pattern proportionally as your altitude and true airspeed increase.
Okay, now that we're approaching Glenwood Springs, I want to keep an eye out for traffic that's departing in the opposite direction. This is normally a one-way airport. It's also important that we set our mixture according to the manufacturer's recommendations for high-altitude approaches. We also want to make sure that we fly the approach at the recommended approach speed. Remember, landing distances are based on you flying that airspeed. Now that we've landed, let's taxi to the end of the runway. We'll turn around and take off back down the valley towards Aspen.
Conditions permitting, after you've taken off from a one-way airport and have attained a safe altitude, you might want to offset the takeoff leg. This will help avoid other traffic on final.
Okay, this is the Aspen Valley. We want to try and stay to the right side. If aircraft coming out of Aspen stay to their right, we should have separation. Also, with the current winds, we can take advantage of any updrafts by staying on this side.
I know we've covered a lot of information during this mountain checkout, but remember, mountain flying can be very rewarding as long as you take the time to review the information that we've covered, such as proper pre-flight planning, remembering that your aircraft may experience some loss of performance, keeping track of your weather, also remembering how to operate your aircraft during high-density altitude situations. There's one thing that you've done that I wish a lot of other pilots would do, and that's take the time for a proper mountain flying checkout. Flying at this altitude is much different than flying at lower elevations.
Yes, I found that out.
Through proper training, we could eliminate a lot of the accidents that occur during mountain flying. And there are a lot of pilots who come up here to see the beautiful scenery that we saw today.
I'll bet.